So this recording explains to you how to use force multipliers and how to solve complex calculations involving force multipliers. This is part of the AQA GCSE physics specification under P3.2, so it's only for triple students. Now, as you can see, the question says a force of 25 newtons is applied to the smaller cylinder of the hydraulic press. So that's that one there. That's the force of 25 newtons. And you've got an area of 8 centimeters squared. It wants you then to calculate the force acting on a larger cylinder. The larger cylinder's got 100 centimeters squared area. Okay, so before I start to show you how to do this, what I've done is put together some hints. So you can move on to the next question. You might want to note that down on your diagram so you know what you're doing. Go on to the next slide here. We've got, I'll just write that down for you. We've got these steps to take, okay? So the following steps. First of all, write down what you know from the question. I've already done that on the previous slide, but we'll do that again in a moment. Calculate the pressure in the liquid due to the force on a small cylinder using the equation P equals F over A, where P is pressure, F is force, and A is area. Then you need to realise that this pressure is the same pressure acting on a larger cylinder because liquids are virtually incompressible. It means the pressure is the same throughout. And once you realise that, you can use this pressure to calculate the force on a larger cylinder. Now you may want to pause the recording now to have a go at this calculation yourself, or you might want to listen to the rest of the recording for me to show you how to do it. So in this part of the recording I'm going to tell you how to write down what you know from the question. So you can see we've got the smallest cylinder I'm going to do in red, so you've got 25 newtons there, 8 centimeters cubed. So that I'm going to call little f, this I'm going to call little a, okay, where little f equals 25 newtons, okay, and little a equals 8 centimeters squared. For my larger cylinder, I'm going to have large f, which is going to be acting up in this case, and large a for area. So large a equals 100 centimeters squared, and large f is our unknown. So now I'll look at step 2. So we calculate the pressure in the liquid due to the force on a small cylinder using P equals FA. Let's write out the equation, and we want to use a small f and a small a. Now we worked these out on the previous slide. I haven't got room to move them forward, but I've highlighted them in the question. So I'm going to work out P equals 25 over 8. You put that into your calculator and you get 3.125. That's going to be newtons centimeters squared per centimetre squared. Now I've left the area as a centimetre squared because my other area is also a centimetre squared, if you see here. So I know that when I multiply through by area later, the centimetre squared will disappear. I'm okay to leave my areas in the units I'm given as long as they're consistent. So if I've got centimetre squared and centimetre squared, that's okay. If I have metre squared and centimetre squared, I'd have to do some sort of conversion. So the next step is to realise that the pressure we worked out earlier is the same pressure in the liquid throughout, and therefore the same pressure acting on a larger cylinder. So the pressure on a larger cylinder is going to be 3.125 newtons per centimetre squared, and that means I've also known my large area, which is equal to 100 centimetres squared. So I'll be able to work out my force, F, from using pressure equals force over area. But we'll look at that on the next slide. So the next step is to substitute these numbers in. I've got here that my pressure is 3.125 and my area is 100 centimetres squared. I've got the equation that P equals F over A. We use the large numbers this time. So rearranging that to get F, we're going to equal P times A. So F is going to equal 3.125 multiplied by 100. And if you put that into your calculator, you get that the force equals 312.5 newtons. And that's the answer you need. You can put box around that. And that's how you do force multipliers for a hydraulic system.